I'm Mr. Ram.
Hi, this is Michael.
And welcome to another episode of Race Economics Cluebook. Today, talking about game theory. So last time in oligopoly, we talked about oligopolistic firms. They have very few firms in the market, and such they're very interdependent upon each other. The pricing powers, the pricing behaviors, and the overall actions are very dependent on each other's actions or each other's existence. And so this turns into game theory. Game theory is basically a theory between two entities, or in this case two firms, when given two choices per entity. Each firm can price high or price low. And then, of course, each firm's pricing behavior or actions impacts the returns for the other firm's behaviors.
Yeah.
So as a result, game theory is a study of these two firms with these behaviors and what their optimal strategy for each firm is and how they relate to each other.
Depends on really in a independent world.
Yes.
Okay.
So let's say there are two firms, firm A and firm B. They can either price their product high or low.
Yeah.
If firm A prices high, and firm B also prices high, then they both make $25 profit.
Yeah.
Firm A makes 25 in blue, firm B makes 25 circled in the purple. If firm A prices high but firm B prices low, then firm A makes no profit, but firm B makes $35 profit, which makes sense because all the consumers probably flock to firm B, which has a lower price.
Sure.
If firm A prices low but firm B prices high, then the same story, firm A makes $40 profit, but firm B only makes $5 profit.
Yeah.
Finally, if both price low, then they both make $10.
Yeah.
Now, this is where dominant strategy comes in when it comes to determining what the optimal strategy for each firm is in terms of pricing.
Yeah.
Dominant strategy is basically the best choice for a firm, no matter or disregarding the other firm's choice. So let's say firm A, right? Firm A, if it prices low while firm B prices high, then it makes $40 profit compared to if it made $25 profit of pricing high. So firm A is better off pricing low if firm B prices high.
Yeah.
However, if firm B prices low, firm A is still better off pricing low because firm A will make $10 pricing low in this case while making $0 pricing high.
Yeah. It's actually pretty simple because just look at 40 versus 25, 10 versus 0. So you know firm A is better off if they price low, no matter what.
Yeah.
But the same story for firm B, because we just look at the firm B's price, the profit, the purple profit, right? 25 less than 35, 5 less than 10. So it's consistent.
Yeah.
So basically, I don't care firm A's pricing. Firm B is always better off by low pricing.
Yes.
Right? So that means firm dominant, kind of like independent.
Yeah.
So I don't care firm A's choice. I'm always going low. And firm A, same story. I don't care firm B's choice. I'm always going low. So dominant strategy really means either firm A or firm B, they are actually independent. They will go for the low pricing. Okay, no matter what. Okay, although the best choice is collusion. 25-25, the total profit is the best, the highest. Although, so dominant strategy does not necessarily means the overall highest profit strategy. Okay, so
and so then we have Nash equilibrium. Nash equilibrium is basically where the equilibrium of behavior for two firms. Now, as Michael just mentioned, in the best case scenario where both firms collude, they will both price high because they will both make a lot more profit than they would both pricing low.
Sure.
And the total profit, $50, is the highest of any situation here, any four situations possible.
Yeah.
However, since when they collude, let's say when they collude, each firm has incentive to cheat. For instance, if firm A in this case was pricing high, but then decided to price low and break their collusion agreement, then firm A will make $40 instead of $25, even though firm B will make only $5 compared to $25. Of course, firm A doesn't care about how much firm B makes; they care how much they make. So they've incentive to price low because they will make more profit. On the same side of the coin, on the opposite side of the same coin, firm B would also have an incentive to price low if both are pricing high. Because if both are pricing high, including, but then firm B suddenly decided to cheat and price low, they will make more profit at 35 than 25.
Yeah.
So each firm has an incentive to price low.
Yeah.
Regardless of what the other firm does.
That's why Nash equilibrium is very important because, as Ray just mentioned, this collusion, although collusion looks like the best strategy for both firms, it's not stable.
Yeah.
Because people will cheat. Yeah. But as we said, 10-10, this is a stable equilibrium. Yeah. Why? Because no one is gonna cheat. Yeah. If firm B cheat, they step out. Okay. Then what's gonna happen?
If firm B cheats in this case and prices high instead of low, they will make $5 profit instead of $10 profit.
Worse off. Yeah. How about firm A cheat? Firm A cheat, then firm A actually makes 0.
Yes.
So if they cheat, either firm A or firm B, they will be worse off.
Yes.
So Nash equilibrium is kind of like no collusion but a stable equilibrium.
Because
okay?
this is basically the equilibrium of their behaviors or their behavioral strategy where they both meet. In this case, when both firms have a dominant strategy, their Nash equilibrium is basically the intersection or the common factor in their dominant strategies. Where their dominant strategies meet. They're both the dominant strategies are both the price low, so the overall Nash equilibrium is the situation where they're both price low.
Yeah, but pay attention that dominant strategy is different from Nash equilibrium. Although there are two basic concepts in the game theory, they are very different. Dominant strategy is not guaranteed. Nash equilibrium is also not guaranteed. And the dominant strategy does not necessarily lead to a Nash equilibrium if the payoff numbers changed. Let's look at.
So let's look at that case discussed, where there's no dominant strategy for one firm. So let's say in this case, firm A and firm B, they both want to price high because the combined profit is the highest. However, firm A, if firm B priced high, will be better off pricing high, but if firm B priced low, will also be better off pricing high as well. However, there's a different story for firm B. Firm B has no dominant strategy. Why? Because if firm A prices high, then firm B would be better off pricing high. However, if firm B prices low, firm A is better off pricing low. And so firm A has dominant strategy to price high no matter what firm B does, because in either scenario they make the most profit. Compared to pricing low. However, firm B's strategy or behavior, optimal behavior, depends on firm A's choice. And so firm B has optimal behavior depends on whether or not firm A already priced high or already priced low. They don't have an overlapping or surrounding strategy that covers all situations.
So that's very important. So in this case, the payoff matrix numbers changed. So we can see, hey, look, now A still has a dominant strategy, but the dominant strategy is pricing high. But firm B is not independent anymore. It's dependent on firm A's behavior. Okay, and then so in this case, we're also going to look at the Nash equilibrium. And in this case, the best strategy, actually 50-45, is in the Nash equilibrium. Why it results in a Nash equilibrium? Because either firm A or firm B will not cheat. Why? Because if they cheat, they become worse off. You see?
Because if firm A cheats, they make less profit at $40 compared to $50. If firm B cheats, they make less profit at $35 compared to $45. So while this is maybe not as obvious or as decipherable as the previous example where both firms had the same dominant strategy. In this case, if we look at it, firm A's dominant strategy, it basically dictates the Nash equilibrium for the situation, for the scenario, and as a result, they both price high.
So actually, that means the best overall strategy is actually in a Nash equilibrium. Okay, and it's a stable equilibrium, so no one is gonna cheat. But I hope you guys also look at this 15-20 low strategy, and we can see it's not in a Nash equilibrium. We're not gonna elaborate that.
Both firms may have incentives. You can figure it out for yourself.
You can actually just figure out why this is not stable. Okay.
So for final clues, game theory is a study of interdependent behavior of two entities with two choices each in this very basic scenario. Of course, you can expand upon that in game theory. Dominant strategy is basically the best choice no matter the other player's choice. Basically, the overlapping strategy. It may not exist in all scenarios. It may not always be the best strategy combined for both firms.
For all
but it's the best strategy for that one individual firm because it's their safest strategy. No matter what the other firm chooses, they always make the most profit compared to pricing or doing the other action.
That's why actually collusion is very difficult.
Because both firms always have an incentive to cheat. And because collusion is usually not the most stable equilibrium. And so there's no need to know the other player's choice because regardless of what the other player chooses, you have the best outcome compared to if you chose the other choice. So Nash equilibrium implies no firm has incentives to deviate from the current choice sets, which once again reinforces why collusion is difficult because collusion is not Nash equilibrium. And so it may also not exist in all scenarios. In the last scenario it existed, but if both firms had no dominant strategy or had very divergent dominant strategies, it could be a scenario where there's no Nash equilibrium where no matter what, each firm has an incentive. One firm has incentive to cheat. And it may also not be the best choice for all firms. However, implies that choices are public information. So
firm A and B, they know the payoff matrix. They know that very clearly, and although they cannot control the other firm's behavior, but they know if the other firm performs this way, they're gonna this number. Perform that way, they're gonna get that number. So finally, I want to just stress that dominant strategy is not guaranteed. Nash equilibrium is not guaranteed. Dominant strategy just means independent strategy, but it's not always available, right? Not for firm A or firm B. Nash equilibrium just means a stable. Basically, it's a stable equilibrium. No one is gonna cheat. And the Nash equilibrium could be a result of collusion. Could be collusion could be unstable. Could be stable. For example, we already discussed a different payoff matrix. Really depends on your payoff numbers. So that's very important to study those strategy and the Nash equilibrium case by case. Okay. See you next time. Bye bye.